Today we're on page 2 of our chapter 5 notes packet. The quadratic formula, section 5.2. You're all familiar with this, so hopefully this will just be a good piece of review here. For any quadratic equation, ax squared plus bx plus c equal to 0, a not equal to 0, the roots of an equation can be found using the formula. Now you may have learned it by singing it. I'll try. It's early morning, so please forgive my voice. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, you can stop laughing now. Let's get serious. The steps for solving quadratic equation using the quadratic formula. Write the quadratic equation in standard form. Note the values of a, b, and c. Substitute the values into the formula and simplify. So we want to solve using the quadratic formula, expressed in simplest form. The two x values are the roots, or zeros, or solutions. All right, so for number 1, let's take x squared plus 8 equals 9x. Let's write it in standard form. So first we'll subtract 9x from both sides. You don't have to show this step. And we have x squared minus 9x plus 8 equals 0. Make sure you put it in its proper place, right? We don't want to write x squared plus 8 minus 9x. No, we want our x squared term, then our x, and then our constant. Again, your x squared term is also known as your quadratic term. Negative 9x in this case is your linear term, and the plus 8 is your constant. We note the values for a, b, and c, and I usually list them off to the side like this. A is the coefficient of x squared, which in this case is 1. B is the coefficient of x, which is negative 9. And c is our constant, positive 8. And we plug into the formula. X equals negative b plus or minus the square root. All right, so I always use parentheses for placeholders. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And now plug in, substitute in our values. B is negative 9, a is 1, and c is 8. And let's simplify. Negative 9 is positive 9, plus or minus the square root of negative 9 squared is 81. Subtract 32. All divided by 2. So this is 9 plus or minus the square root of 81 subtract 32 is 49. And this happens to be a perfect square. Its square root is 7. 9 plus or minus 7 divided by 2. And we have 9 plus 7 divided by 2, which is 16 divided by 2 is 8. And 9 minus 7, which is 2 divided by 2 is 1. So we have two solutions, two roots, 8 and 1. Next, number 2, again, in standard form. Now my x squared term, the 3x squared is over here on the left-hand side, but it's positive where it is. We always like to start off with our quadratic term being positive. So I'll leave that there and bring the two terms from the right-hand side over to the left by subtracting 8x and adding 2. Okay, so now our quadratic equation is in standard form. Pull out the values for a, b, and c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. And plug into our formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 8 goes in place of b, 3 in place of a, and 2 in for c. Negative 8 is positive 8, plus or minus Again, you can do this in the calculator if you want. Just key it in as it is without the square root symbol. This is going to be 64 minus 24 all over 6. 8 plus or minus the square root of 40. Let's simplify the radical. We're thinking 4 times 10, and the square root of 4 is 2. So 8 plus or minus 2, square root of 10 over 6. All right, now let's break this apart and simplify. So this is 8 divided by 6 plus or minus 2 square root of 10 divided by 6. This would reduce 4 and 3. So 4/3 plus or minus, this reduces 1 and 3, square root of 10 over 3. Next, number 3. And you can always stop, pause the video, and try it on your own if you like. Again, this is not new to you. You had this last year. It's already in standard form, so I'll note the values of A, B, and C. Plug into the formula. X equals negative B plus or minus the square root B squared minus 4AC all over 2A. Negative 4 in for B, 2 in for A, and the C value goes at the end here. Alright, so then this is a negative 4 is positive 4 plus or minus the square root of 16 minus 40 all over 4. It's 4 plus or minus the square root of negative 24 all over 4. Square root of negative 24 is not a real number, so there's no real solution. Because of the negative under the square root. Right? Negative, the square root of negative 24 is not real. So again, there's no real solution. But of course we won't stop there. In just a couple of sections, we will call this what's an imaginary solution. But that is to come in a few more sections. Okay, and the last one on this page, again, let's place this in standard form. Add 9 to both sides. X squared minus 6x plus 9 equals 0. Note the values of A, B, and C. 1, negative 6, and 9. Substitute into the formula. Okay, so our A value is 1, and the B value is negative 6, and the C value 9. X equals, again, a double negative is going to be positive 6, plus or minus the square root of 36 minus 36 all over 2. 6 plus or minus the square root of 0, which is 0. So 6 plus 0 divided by 2 is 6 over 2, which is 3. And 6 minus 0 is 6 divided by 2 is 3. This is what we call a double root. You need not write it twice. Okay, so tomorrow in class we'll do some practice with the quadratic formula. I would like to go on to the top of page 3 though. Right? You notice here with these problems, when what was underneath the square root, like in number 1, when that was a perfect square, our roots here were real, rational, and unequal. In number 2, when what was underneath our square root was not a perfect square, our roots here are real. These are real roots, but they're irrational because of the square root of 10. And they're also 2 different roots. They're unequal. When we ended up with negative 24 underneath the square root, we had no real roots. And the last one, when what was underneath the square root symbol was 0, our roots were real, they're rational, but they're also equal. Okay, and that leads us to what's called the discriminant. Now, the discriminant, given a quadratic equation, ax squared plus bx plus c equals 0, the value of b squared minus 4ac is called the discriminant. When a quadratic equation is solved for x, the values are called roots. The discriminant determines the type of or nature of the roots. Consider the following. Once simplified, what can we say about the 2 x values in each? Are they real or imaginary? Now, imaginary is not real. Rational or irrational? Equal or unequal? All right, so we have x equals 3 plus or minus the square root of 25 over 2. Well, the square root of 25 is 5, so this would be 3 plus or minus 5 over 2. So we have 2 roots. 3 plus 5 is 8, divided by 2 is 4, and 3 minus 5 is negative 2, divided by 2 is negative 1. So these roots are real, they are rational, and they're unequal. And that's because the discriminant value was a perfect square. Number 2, we have 3 plus or minus the square root of 27 over 2. Well, the only thing we can do is we can simplify 27 here. This would be 3 plus or minus 9 times 3 is 3, so 3 square root of 3 over 2. We have 2 roots here. We have 3 plus 3 square root of 3 over 2, and we have 3 minus 3 square root of 3 over 2. So we have 2 different roots here, but they are both real. They're real roots. They're irrational, and they are unequal. They're 2 different roots, so they're unequal. And we see this when the discriminant value is greater than 0, but not a perfect square. Next, 3 plus or minus the square root of 0 over 2. Well, the square root of 0 is 0, so we have 3 plus or minus 0 over 2. 3 plus 0, 3 divided by 2, and 3 minus 0 is 3 divided by 2. So here we see that the roots are, these are real numbers. They are rational, but in this case they are equal. And we'll see that when the discriminant value is 0. When your discriminant value, what's underneath the square root, the value of b squared minus 4ac is 0, your roots will be real, rational, and equal. And the fourth one, x equals 3 plus or minus the square root of negative 5 over 2. Again, because this value here is a negative value, the roots are not real. They're going to be called what's called imaginary. They're not real. Okay, so we will pick up here with our next video, and it's summarized here in the table for us, but we'll leave that for our next video. So this completes our video for tonight.